Hello guys, welcome to another video from Computerscience channel. In this video, we're gonna solve the ninth problem, actually the question number 9 from Sipser textbook, and this is like the last problem that we solve is about NFAs and actually the property of concatenation in NFAs, and we will solve this problem and learn some things about the theorem of that area of regular languages is closed under concatenation, and actually we will practice this more and more. And yes, that's it. Let's solve it together. Okay guys, as you can see, this is the question number 9 from Sipser textbooks. It says that use the construction in the proof of theorem 1.47 to give the state diagram of the NFAs recognizing the concatenation of the language described in part A and B. First of all, let's take a look at theorem number 1.47. Actually, this is the theorem. It says that the class of regular languages is closed under concatenation operation. Actually, the basic idea of that is that if you want to concat actually A2 to A1, or better I say N2 to N1, all we have to do is that define some new arrows for epsilon transition actually from the acceptable state of N1 to a certain state of N2. So as you can hear, these are the certain state of N1. All we have to do is that define these epsilon actually arrows to a certain state of N2. And yes, that's it. This is all we have to do if we want to construct the NFN base of concatenation. So now, actually, let's back to our question. Part A says that exercise 1.6 part G and 1.6 part I. We must construct an NFA for concatenation of these two languages. And actually, I write the questions here. Yes, that's it. For part A, the first part is that the length of W is at most 5, and for part 2 is that every odd position of W is a 1. So now let's actually construct the DFA for L1. Actually, for L1, DFA for L1, we can actually, based on this condition, we can accept the string until we reach the length of 5, and before that we accept all of the strings. So actually it will become something like this. If I want to show you, the first state is epsilon, and we know that the length of epsilon is equal to 0, so we will accept it. And after that, for any 0 and 1 transition, we will go to our next state. Actually, our string become one number bigger. So actually, in the second state, the length of our string is equal to 1. And after that, another transition. And here, the length of our string is equal to 3. And after that, the length of our string actually, what I say, equal to 3 here. Actually, sorry, the last part was equal to 2. And after that, this one is equal to 4. And here, this part equal to 5. Actually, so the first state here, actually, our length is equal to 0. Here, 1 and 2 and 3 and 4 and 5. And we know that after that, we will actually go over our conditions. So we can never, after that, reach our acceptable state. So it will become like this. And yes, this is a DFA for L1. Actually, for L2, L2 says that every odd positions of W is a 1. So actually, if I want to construct the DFA, actually, I think there is an ambiguous in this language, actually, because in epsilon, we know that the length of epsilon is equal to 0. And actually, epsilon don't have any lengths actually equal to some odd numbers. So Here we don't know, actually we can't accept the epsilon or not, but we assume that we can actually accept the epsilon. So our DFA actually become like this for L2 if we accept the epsilon. So the first state is our actually starter state and we can accept it. This one is equal to epsilon. After that, we know that in every odd position, we must have a 1. So if after this part we see a 0, we will go to here. And in this state, we can't never actually reach our accepted state. So it will become like this. And basically, if we see a 1 after this, like this, we will reach this state. And we know that this is our accepted state because in this state, actually, this is a state of our odd position, and in this actually state, it's equal to 1. So yes, this one is true. And after that, if we see a 1 or 0, it doesn't matter, because after that, our string, actually the length of our string is equal to an even number. So actually we basically reached our condition and it does not matter for us. So it will become like this. And yes, actually this is the DFA for L2. And now, after all of this, we must construct a NFA that can recognize in the language, actually this language, the concatenation of L1 and L2. So first, we must draw the DFA for L1 again, and actually it will become like this if I want to draw it so fast. Actually, sorry, here. And yes, this is our accepted state 2, and another accepted state, and another one. Actually, you know, all we have to do is that repeat some works, actually define the transition for 0 and 1, and define our accepted states. And after that, in this state, our length is equal to 5. Actually, I think here is equal to 0 and 1 and 2 and 3 and 4 and 5. And actually, after that, we have these states here, and yes, that's 8 here. Our length is equal to 6. So actually, based on our theorem, we must define some epsilon arrows for our accepted state in L1 to a started state of L2. So we will erase our accepted state actually like this. Sorry. And actually erase these numbers and define some new epsilon arrows like this from our accepted state in L1. All of these arrows are epsilon, so it's like this. And here, actually, if I want to construct it, this is the starter state of L2. So let me draw it better. Yes, all of these arrows go to this state here, and after that, all we have to do is that construct the DFA of L2, and it will become actually like this. We have transition for 1 here, and we know that this state here is our accepted state, like this one too. And if we see a 0 here, we will reach this state. And yes, that's it. Actually, this is the NFA that can recognize the concatenation of L1 and L2, and it will become like this actually. And yes, that's it. That was for part A. Now let's go to part B. Part B is the first part says that W contains at least 3 ones, and the second part says that the empty set. So first, let's construct the DFA. Actually, I will construct it here for L1. W contains at least 3 ones. So we know that actually we must go over and over and over again until we reach actually better I say a string that contains at least 3 ones. So we can accept our first state because in this part we don't reach our condition, and we know that here the number of zeros doesn't matter for us. So we will draw the transition for them like this. And now here the number of ones is equal to 1, and after that equal to 2, and after that here it's equal to 3. So this is our accept state, and after that we can accept any string, because in this state here we reach our condition, and actually after that we can accept any string. So it will become like this. Yes. And for L2, actually the empty set says that we can't accept any string. Actually, better I say we don't have any accept states here. So we can draw it like this actually. Yes, this is the empty set. And we don't have any accept state here. We can't actually accept any string. And yes, that's it. Now let's construct the NFA for concatenation of L1 and L2. First, we must draw the language L1, actually the DFA for language L1 again, and it's like this. It will become like this. Actually, yes, another state here and another one, and this is actually our accept state in L1. All we have to do is that raise that accept, actually symbol somehow, and define a new arrow, actually a new epsilon arrow to start a state of L2. And we know that based on this question, L2 has only one state. And yes, that's it. And it will become like this actually. And if you notice here in this new NFA that we construct here, we don't have any accept state, so we don't accept any string. And actually somehow we can notice that the concatenation of an empty set actually to any language will become an empty set. So you can notice this part, that the concatenation of empty sets actually to any language will become like this, actually another empty set. And yes, that's it. That was the answer for question number 9 in Sipser textbook. I hope you guys enjoyed this video and learned a lot of useful things about, I don't know, concatenation, DFAs or NFAs, and actually issues like these. If you like this video, like it and subscribe to my channel. And if you have any idea that can help me somehow raise my channel, actually become better in my work, actually I become happy to read your comments. You can leave your comments in comment parts. And yes, that's it. Have a nice day, guys. Goodbye.